Let's create the BookEntity class. This class represents our book entity and is mapped to a database table named books. We'll be using several annotations from JPA and Lombok for simplicity. Let's annotate our class with @entity and @table to specify the table name. To avoid writing getter and setter methods, constructors, and toString method manually, we use Lombok annotations. For the primary key, we use @id and @generated value annotations. We'll generate the ID using a sequence generator. Next, let's define the book code. It's a required and unique field, so we will use @column, @not empty, and unique equals to true. For optional fields like description and image URL, we simply declare them without additional annotations. Lastly, we define the price of the book. It's a required field with a minimal value constraint. So we use @not null and @decimal min. Now, let's create the book repository interface. This interface will allow us to perform CRUD operations on our book entity. We'll use Spring Data JPA to simplify our data access layer. By extending JPA repository, we get several methods for free such as save, find all, find by ID, and delete by ID. These methods allow us to perform basic CRUD operations without writing any implementation code. Now, let's add a custom query method to find a book by its code. This method signature tells the JPA to generate a query to find a book entity by its code field. It returns an optional book entity, which means it can contain a found book or be empty if no book is found with the given code. And that's it. Our book repository interface is ready to use. We'll create a book record and a utility class to map between our book entity and book objects. Records in Java are a special kind of class that automatically provide us with getter methods, a constructor, equals, hash code, and toString methods, making our code more simpler and more concise. The book record has 5 fields: code, name, description, image URL, and price. This record will serve as a simple DTO in our application. You might be wondering why we didn't include the ID field here. As a best practice, we usually don't expose the internal IDs in our DTOs to avoid potential misuse or leakage of sensitive information. Instead, we focus on the fields that are relevant for the business logic or the presentation layer. Now, let's create the bookmapper utility class. This class will help us convert between book entity and book objects. Using a mapper class ensures that our conversion logic is centralized and reusable. The utility class annotation makes the class final, provides a private constructor, and makes all the fields and methods static, which is perfect for utility classes. Now, let's add a method to convert a book entity to a book. This method takes a book entity as a parameter and returns a new book object. It maps each field from the book entity to the corresponding field in the book. Let's add a method to convert a book to a book entity. So now this method takes a book as a parameter and returns a new book entity object. It uses a builder pattern to create the book entity, mapping each field from the book to the corresponding field in the book entity. Let's dive into creating the book service class. This class will be responsible for handling the business logic of our application. We'll annotate it with @service to indicate that it's a service component in our Spring application, and we'll use @transactional annotation to ensure that the methods within the class are executed within a transaction. Next, let's define the class itself and inject the book repository using the constructor injection. Now, let's add a method to retrieve a book by its code. This method uses the book repository to find a book entity by its code and maps it to a book object using book mapper. Next, let's add a method to create a new book. This method converts a book object to a book entity, saves it, and then converts the saved entity back to a book. Next, let's add a method to update an existing book. This method finds existing book by its code, updates its field with the new data, saves the updated entity, and then returns the updated book object. If no book is found, it returns an empty optional. Finally, let's add a method to delete a book by its code. So let's talk about exception handling. We'll create a custom exception class to handle cases where a book is not found in our database. This class has a constructor that accepts a message which is passed to the superclass runtime exception. Let's add a static method for code that creates an instance of book not exception with a custom message specifying that a book with the given code was not found. We'll also create a global exception handler to manage different types of exceptions in a standardized way. So when developing a RESTful API, it's very critical to handle exceptions and provide meaningful information in error responses to clients. Spring Boot 3 introduces the problem detail specification, which allows us to create standardized and structured error responses. Let's dive into creating Global Exception Handler class. This class will handle various exceptions that might occur in our application and provide a consistent response structure using problem detail. We define the class itself and annotate with @REST_controller_advice to indicate that it provides centralized exception handling across all request mapping methods. So let's add method to handle general exceptions. This method handles all unhandled exceptions by returning a problem detail object with the status of 500 internal server error. So we will also handle the custom book not found exception, which catches the book not found exception and returns a problem detail object with the status of 404 not found and a custom error message. Add another method to handle type mismatch errors. This method handles method argument type mismatch exception by returning a problem detail with the status of 400 bad request. Now let us also create a helper method to build the problem detail objects. This method constructs a problem detail object with the provided status, type, title and detail, and adds additional properties like service name and timestamp. In this way, our global exception handler class provides a centralized way to handle exceptions in our Spring Boot application, ensuring constructive and informative error messages. So now let's create the book controller to expose our service layer methods as RESTful endpoints and handle exceptions appropriately. We'll annotate it with a REST controller and we'll also use request mapping to specify the base URL for all our endpoints in this controller. We'll inject the book service using constructor injection. Let's add a method to get a book by its code. This method handles getRequest and it uses a book service to fetch a book by its code and returns the book if found or throws a book not found exception. Now let's add another method to create a new book. This method handles the post request to /API/books. It creates a new book using the book service and returns the created book in the response. Now let's add another method to update an existing book. This method handles the put request to /API/books/code. It updates the book with the given code, and if the book is found and updated, it returns the updated book. Otherwise, it will also throw book not found exception. Now let's add our final method to delete a book by its code. This method handles delete requests and deletes the book with the given code using the book service. We are done with the code part and we are now going to test our Spring Boot RESTful API for the BookStore application that we have created so far. We'll use the Postman to test our API endpoints. Before we start, make sure we have all these properties set in the resources application.properties file. Ensure that your MySQL server is running and the BookStore database is created. Start the Spring Boot application and make sure it's up and running. Now, Let's start by testing the Create Book API. Open Postman and create a new post request to http localhost 8080/API/books. In the body, select raw and JSON, and we would have a code, name, description, image URL, and price. Now click the send button to create the new book. If everything is set up correctly, you should see a response with the details of the newly created book. Next, let's test Get by Book Code API. Create a new GET request to http localhost 8080/API/book/123. So this will fetch the book with the code 123 that we just created. Hit the send button and you should see the details of the book in the response. Now, let's update the book. Create a new put request to http localhost 8080/API/book/123, and in the body just add all the details, and let's say we change the name from sample book to updated book name. Now click the send button to update the book. You should see the response with the updated book details. Finally, let's delete the book. Create a new delete request to http://localhost/8080/API/book/123. Click the send button to delete the book. You should see a 204 no content response indicating that the book has been successfully deleted.